Hey everybody, Zachariah J here, back with part 2 of exam 4 review for the IVC Precalculus class. This exam covers parts of chapter 5, chapter 10, and chapter 11, but this video is only the part comes from like chapter 10 and 11. So it starts with question number 13 on our review. I would like to also point out that I am not the instructor. I am just another student. So if I make little mistakes, don't hold the IVC accountable or our instructor accountable or anybody like that. If you do see mistakes, go ahead and feel free to point them out in the comments. Troll me all you want. But without further ado, let's get on with question number 13. So in number 13, we're given these vertices and this asymptotes. So right off the bat, we know because we have asymptotes, it's not an ellipse, it's not a circle, it's a hyperbola. Additionally, we see these negative 3's here, so it's all along a y-axis, or sorry, a y equals negative 3, so it's along this on a y-axis at negative 3. I guess y-axis? It's on y of negative 3. So it's not really the y-axis, but anyway, I think you get what I'm saying here. We're going to have a left and right opening to this hyperbola. And x is the positive value in this case because of we know which way these are going to open. So we're going to have x squared over a squared minus y squared over b squared, and that equals 1. So we can start filling this in. We have these two parts here. So x plus 2, that quantity squared is in place of our x over, it's going to be a squared. We'll figure that out in a minute. Minus y plus 3 squared, and that'll be over our b squared, which we'll also have to figure out here in a moment. So the question is, how do we find all that stuff? Well, we start with our center. We know our center is going to be the opposite of what's on the top there. So we'll do negative 2 comma negative 3. It also came out of the asymptote there, as you can see, but technically from the formula, it's h and k. So again, we're going to look for what is a and what is b. And a is going to be the distance between negative 2, our x coordinate of c, or of a center, and 1/2. And it's going to be the absolute value since we have some negatives involved. So basically we have negative 2 as our center, and this 1/2, just pick one of the values here. I picked 1/2, and it's going to come out to be 5/2. That's the distance between those two numbers. And actually, I should have set this up the opposite way. 1/2 plus negative 2, and that absolute value. Now you would work out that you would get, it still kind of works out funny. But anyway, you still get the idea. Between negative 2 and 1/2, it's a distance of 5/2. A squared would be 25 over 4. So we can just put that here, 25 over 4. Now let's find out what b is. Well, we don't have a direct way to just pull b out of something, but we do have our slope here. And since that's going to be b over a, and that equals 6/5. And the reason I know it's b over a is because the x and the a's are first here, and the x is with a. So that's how I know that this is b over a. Now I'm just going to substitute my a, which is 5 over 2, into that formula, or into that equation. So we have b over 5/2 is equal to 6/5. And we flip the denominator over, multiply it, then we get 2b over 5, and that equals 6/5. Now we're going to multiply times 5, so 2b is equal to 30 over 5, which reduces to 6. So, and then obviously 6 is divided by 2, and that gives us 3. So b is equal to 3, but remember, b squared goes under here, so we are going to say 9. So I'll rewrite this all together over here, and that's the quantity x plus 2 squared over 25 over 4 minus the quantity y plus 3 squared over 9 equals 1. So we were asked to find the equation for this hyperbola, or these values rather, and that would be the answer right there. Moving on to number 14, same kind of question, except they've given us some different pieces of information to try and figure out what this formula is going to be. And right off the bat, we can see that we can just plot this. This is going to be a 2, 8. It's going off my graph already. And then our foci, or our vertex is 1, 8. And then our foci is, or one of our focuses is clear over here. So you can see this is going to be on a line like this. So we're going to get, it's going to be closer than that. Anyway, it's actually not quite right, but you get the point that we're going to have a left-right opening. So clear all this space out, and we will do our magic. Since we know it's going to be an left-right opening hyperbola, we know that the x is going to be the positive portion of this equation that we're going to find. So x is going to come first. So we have x minus 2 squared minus the y minus 8, that quantity squared, and those will both be over something. So the x will be over the a and the y will be over the b again. All this will equal 1. And I pulled that from knowing the center. It's the opposite of the ordered pair in the center. So that's where those numbers came from. Now, what is my a and what is my b? What is my c for that matter? We'll figure all that out. So we look at the center point, and that is -5, 8. Oh, wait a minute. That is the focus, not my center. It's really late. It's 1 in the morning. I'm working on this. We want to work with our vertex and our center here. So we're looking at our 2 and our 1 here, actually, and the difference between those, or the distance between those. So 2 minus 1 is equal to 1, and that's our a. So we'll just put that under our x value here. So that's our a. Now we need to find out what our b is. However, we are not given an exact way to figure that out. I mean, we're going to have to use c squared equals a squared plus b squared. So we'll use this -5 to find that distance, and that distance is 7. So that's our c. So c squared equals a squared plus b squared. Substitute all that in. We will get 49 equals 1 plus b squared. Then we'll get 48 equals b squared. And since b squared is what we're looking for the underneath the y, we'll just throw the 48 up there. Question's only asking for the equation, so there you have it. Moving on to number 15. So now we're asked to graph this equation. So to graph this equation, we actually need to find these four values, or four items. We need to find the center, the vertex, the foci, and our asymptotes. So we'll just take this whole thing and divide it by 4 so we can get this into our standard form. So we have x plus 2, that quantity squared, over 4, minus y minus 1, that quantity squared, over 1, because the 4's will cancel. And then, of course, this will equal 1. So, boom, there you go. We've got our standard form equation. So we need to find out what our A is, our B. Our A is 2, and our B is 1. And we'll need to find out what our C is going to be here in just a minute. So the square root of 4 is 2. That's our A. And the square root of 1 is 1. That's our B. So to find our C, we have C squared equals A squared plus B squared. So we can just sub in what we know. So we got 4 plus 1. That's 5. So C squared equals, oops, I'm getting too far ahead of myself. C is equal to plus or minus square root of 5. C squared was equal to 5. Move that squared over. That's what you get. So we can put here plus or minus square root of 5. Now, we know that the x is the positive, so we're going to get a hyperbola that opens left and right. So come on, pen. Actually, let's write down our center here. Just get that out of the way. It's negative 2 and 1. And so our vertex will be defined by this A, and that affects our x number, our x value of center. And that same thing goes for the C. Since our hyperbola opens left and right, we're going to use these values and add or subtract them from our x value in our center point. So it's negative 4 comma 1 and 0 comma 1. That's the A values, which gets us to our vertex. Now, if we want to get to our foci, we need to go plus or minus negative 5 from the center. So it's negative 2 plus or minus, square root of 5, comma, not parenthesis, 1, parenthesis. So that's where our foci are. Now we need to figure out what our asymptotes are. And this, we can just find our slope. Our slope is going to be b over a, because the x is the value in the front and it has an a underneath it. So that's why the a is on the bottom for our slope. So we will put in b over a, and we get 1/2. So we can just take our points from the top of our equation. So y minus 1 equals 1/2 x plus 2. And that's what's going to define our lines for our asymptotes. And really, this is going to be plus or minus 1/2, because we have 2 asymptotes. So I probably should put plus or minus in there. But start plotting all these things. We got negative 2, 1, negative 4, 1. We got 0, 1. And then we can start figuring out where our asymptotes are going to be. And since our slope is 1/2, You go up 1 and over 2, down 1 and over 2, and that defines one of the slants. And the other slant is just a mirror of that, so we can just put our other corners here. I mean, this is basically creating the box that they're kind of showing in the book, and they showed us in class. But I prefer just to use the slope. It's just as easy for me. But if you like the box, you can see the box is created by those 4 points. I'm just connecting the center with the corners of the box, or the points that I plotted using the slope. And those are asymptotes. So this is how our lines are going to, or hyperbolas are going to be following the asymptotes. There we go. And that's pretty much how we graph that little guy. Now we'll move on to number 16. And again, we're given an equation, and we need to figure out how to graph it. So first thing, we find our center, which is going to be -2, -2, pulling that from the top there. Our A is going to be 2, which is the square root of 4. And our B is going to be 5, which is the square root of 25. And our C is going to be C squared is equal to 4 plus 25, which is 29. And so C is equal to square root of 29, plus or minus. Which, if you put it into a calculator, it's about 5.34. So we know that our A is going to be affecting our X value again. Put our 29 in here, or square root of 29 rather. And that also will be affecting our X value. This is how we're going to find our vertex and our foci. The X was first, so we know that we're going to have the left-right opening. That's how we know that this is affecting the X. Oh no, I'm running out of battery. So we're going to have a vertex of our X. Our center was -2, so we're going to add and subtract 2 from that to make 2 different points. So -4, -2, and then 0, -2. Those are our 2 vertexes. Now we come to the foci, it's the C value that is going to be added or subtracted to the X value of our center. So we have -2 plus or minus square root of 29, comma, -2. There you go. That's our first 3 sections. Those are pretty quick and easy with this problem. Now we can look at our asymptotes, and because the X is first, it's mated with an A underneath it, so that means that we are going to have B over A for our slope. So we know what our B is. Just put this over here. Slope is going to be B over A because this A is with the X here. That's the way I remember it. I know our instructor has another way he remembers it, but so we'll do y plus 2, and then our slope, and then the x plus 3. Where did I get the 3 from? Wrongo. 2. There we go. So anyway, As far as the slope goes, all of our examples here are x is the positive. So if it were y positive, then the y would be over the a, and the x would be over the b. So then I'd know the b would go on the bottom for the other parts. So that's how I figure out what the slope is, whatever x is mated with in the equation. So we'll start plotting all these things. Here's our center. Here's one of our vertexes. Here's the other vertex right here. Um, if we were to plot our foci, that's why I did this little calculator bit here. It got 5.34. That's from the center. Plus or minus 7 point. Oh, wait a minute. It's negative 2. Plus or minus 5.34. Fix this. Negative 2 plus or minus 5.34. Trying to do too much in my head at the same time. So anyway, um, that would be a negative 7.34 and, or actually, and the other x value would be 3.34. Yeah. So if we wanted to plot those on that negative 2 axis, we basically would plot 3.34, negative 2, and then negative 7.34, negative 2, and then label those as our foci. We've plotted the first 3 items on our list. Check, check, check. Now we have a slope of 5/2, which if we go from the center, we're going to go up 5. 1, 2, 3, 4, 5. Go over 2. Boom. There's one corner of the box. If we went down 5, go the other direction 2. Boom. There's the other corner of the box. Um, Still kind of, I don't draw the actual box. I just plot these corners and then connect the 3 points, the center and the 2 corners there. So I'm kind of maybe doing half box, half not. I don't know. Anyway, here's one of the asymptotes. Here's the other asymptote. And then we'll draw our lines that are going to go through our vertices and then hug the asymptotes. Excuse me. There's this side. And then here is this side. That's number 16. And it matches what we had, what we guessed. All right, so now on to 17. 2 recording devices are set 2,200 feet apart with the device at point A to the west of the device at point B. All right, sketch that. At a point on the line between the devices 300 feet from part B, a small amount of explosive is detonated. A little smoke stream here. The recording devices record the time the sound reaches each one. How far directly north of Site B should a second explosion be done so that the measured time difference recorded by the device is the same as that for the first detonation? So let's label these points. This is our second explosion, XY. Our middle point here, we can call that 0, 0. That means A is negative 1100, 0. And our recording device B, it would of course be at 1100, comma 0. And we can call this, instead of XY, we can call it actually 1100, comma Y, because we don't know what Y is. Well, I put 0. That's wrong. But I redrew this whole thing off to the side over here without all the explosions. I thought the explosions would be fun. So here I've got it written correctly. So we've got that 1100 comma y, and part of the hyperbola, and here's our two explosions, our explosion points. And if we think about this problem the way that they want us in the book to solve it, we'd really need to find our center, our vertex, and our focus on this side over here. So our center, we already set it at 0, 0. And then our vertex is actually going to be 800, 0. It's this point here. Oops. I actually have 300 written here, which is 300 from the speaker, but not 300 from the center. So let's fix that. This point is actually 800, 0. And then that's this section here. That's 800, that portion of the line. And this portion of the line is that 300 that came from the word problem. Really poorly worded word problem. But anyway, so the total of those together is 1100. So our vertex, well, our vertices really would be plus or minus 800 comma 0, because technically we have the same point over here. That would be the reflection, and here's the other half of this hyperbola that we would have had. Well, actually it's a quarter because I'm not drawing the bottom part. But anyway, our focus is, well, our foci rather would be plus or minus 1100 comma 0, because we have one on each side, so really should be foci, but we are only going to really need to deal with the one side, so the one focus. Now, our problem that we're going to be looking for here is going to be x squared over a squared minus y squared over b squared equals 1. So we just need to find all of our values here. We need to find a, which a squared is 800 squared. That's this portion right here, the distance from the center to the vertex. So that's a. So a squared would be that number squared, so 800 squared. Our b, we don't know what that is, but we're going to calculate that number. Because we do know what C is, and that's the distance from the center to our focus, which is 1100. So we'll pull that down into the equation. So that distance right here is 1100. So actually it's not in an equation yet, but anyway, C is equal to 1100, and these of course are squared. All right, so we know that we have the Pythagorean theorem looking formula, a squared plus b squared equals c squared. And since we have two of these variables, it should be pretty easy for us to find out what the third is. So we'll just plug and play. 800 squared plus b squared equals 1100 squared. We're just going to redistribute this 800 to the other side, so subtracting 800 squared from both sides. So we have b squared equals 1100 squared minus 800 squared. Now, just plug this into a calculator real quick, and we will get b squared is equal to 570,000. So there you go. We now have pretty much all the information we need to plug into our hyperbola equation, so then we can solve for y. So our x is that 1100. Remember, we're looking for the 1100 comma y. We're looking for that point. So 1100 squared over 640,000, which is 800 squared. This portion right here. I don't know why I didn't calculate out the 1100, but anyway, we already have the b calculated out as a squared. So 570,000 goes under here equals 1. Now we're just going to subtract this first portion of the equation from both sides. So that means we'll have a negative y squared over 570,000 on this side. equals 1 minus 1100 squared over 640,000. Now we'll multiply by a negative 570,000 to both sides. That will help us clear the negative from this portion. Need a little more room here, so I'll just move all this stuff over here. And bring our next step will go up here. So we'll multiply it by negative 570,000, leaving y squared by itself. Positive, obviously. So we have negative 570,000 times the quantity 1 minus 1100 squared over 640,000. Now we take the square root of both sides, leaving y all by itself, which is what we wanted. Oops, here we go. Negative 570,000 times the quantity 1 minus 1100 squared over 640,000. And of course, I am not going to do this in my head, so using the calculator. And we will get y equals 712.5 feet. So that point above B is 1100, comma 712.5. So it's a coordinate. So, and actually that's not our answer. Our answer is just y equals 712 and a half feet. They just want to know how far above B it is, so we don't need the other half of the coordinate. Now, another way we could look at this is we could use a distance formula. So we could set A as our 0, 0, and our B would be 2200, comma 0. So it's that far away. And our midpoint would be 1100. We don't need this 2200 anymore because we put it in that coordinate for the B. Our midpoint is 1100, 0. There you go. What else do we need to do here? Oh yeah, so add 800 to this. That's the 1900, comma 0. Got my parenthesis over here. So now we have our 300 feet from the B. The remaining to the midpoint would be 800, and then the rest of this line is another 1100. All that totaled up is our 2200. Now we have this explosion that we're supposed to have north of B or above B. So we can mark that explosion right here. And here was our first explosion at the 300 point, 300 from B. And basically, we have this triangle. Since we were using the Pythagorean theorem ultimately anyway, maybe it's quicker to do it this way so we don't have to do as many steps. Might be the same amount of steps. Anyway, this is distance 1 and this is distance 2. We already know the other distance is 2200 feet. So we're looking for these two distances. And distance 1 minus distance 2 is going to be equal to 2a. And our a is the 800. So mark this for our a. So we need to find out what our distance 1 is and our distance 2 is. We'll plug those in. Actually, we'll find out what our distance 1 is. We'll plug that in, and we'll plug in 2a in, because we know what that is. And then we'll be able to find our distance 2. This point up here is 2200 y, of course. And d2 is going to be equal to y because this is a right triangle, right? It's straight above. It's supposed to be directly north versus the other speaker or the recording device A is directly west. So we don't have to make a whole distance formula for it. We just know it's equal to y. but distance 1 is going to be equal to, let's label this one x sub 2, y sub 2, and this one up here x sub 1, y sub 1. And we'll plug that into the distance formula, which is x sub 2 minus x sub 1. So our x sub 2 is 0 minus x sub 2, which is 2,200 feet squared, plus y sub 1, y sub 2, which is 0 again, minus y sub 1, which we don't need to put a sub 1 because we don't have another y to get confused with. So we square those. And then that reduces down to distance is equal to negative 2,200 squared plus negative y squared, the quantity negative y squared. I guess it's important to make that distinction because whatever this turns out to be, it's going to be a positive value because, you know, negative times a negative is positive. So down here, we will end up with negative 2,200 times itself is 4,840,000. That's a positive number. And then we don't know what y is, but we know whatever it's going to be positive because there you go. So but we still have the squared here. So we kind of just eliminated this part of it. So that is the equation to find D1. Now we can just plug that in to our equation that we have over here. So let me get another color here. Thicken up this color. We'll use that same color. So we have the square root of 4,840,000 plus y squared minus the d2, which is y, and that's equal to 2a, and that is this part right here. So 800 times 800, 1600, sorry. 800 plus 800 is 1600. All right. So we square both sides to get rid of this radical. Or actually, first let's move this y over. We'll move the negative y over so we'll have it to equal 1600 plus y. Now let's square both sides so we can get rid of this radical. Plus y squared equals, and then this is effectively the quantity 1600 plus y squared. So we have to FOIL this guy out. Oops, hang on a second. We want this plus y. Now close parenthesis, and then we'll write the rest. So 1600 times 1600. It's a big number. Use a calculator here. We'll get 2,560,000 plus, and then it's going to be 1600 plus 1600 is 32, and that's going to be y, 3,200 y's plus y squared. Now you can see if we subtracted y squared from both sides, these would just cancel out. So now we have this large numbers and the millions here left. So we subtract 2.5 million, 2.56 million from both sides, and we will get, that's going to be 8, and that's going to be 2, and that's 2. Yeah, so 2.28 million. So we will have 2.28 million, lots of zeros here, is equal to 3,200 y. Well, we divide both sides by 3,200, and that is going to cancel the 3,200 on one side, which is what we want. So we have 2.28 million divided by 3,200, and we plug that into a calculator, and lo and behold, we come up with the same numbers we did using the other formula. So y is equal to 712.5. So just a different method. Moving on. So for number 18, we are solving a system of equations with three variables. I'm going to choose to get rid of the z because this one's already set up to do that, so I don't need to do any crazy multiplication or anything. So I'll just carry these two equations over. 4x plus 3y plus z minus negative 15, or equals negative 15. 3x minus 5y minus z equals negative 15. Add them together, 7x minus 2y. The z's cancel out, so and this is all going to equal negative 30. So now I have to use two other equations. So I'm going to use this middle one again, and I'm going to use the bottom one. But I'm going to have to multiply this times 4, so the negative 4 and the positive 4 will cancel out the z again. So this ends up being 12x minus 20y minus 4z equals negative 60. And then I just bring the bottom equation over here just straight over the way it is. 4x plus y plus 4z, I'm sorry, 4x, well, this will equal 23. Add this all together, I get 16, and I don't know why I put this 5 here. Where was I getting that from? It's supposed to be just y. There we go. Plus y. It's this equation right here. I pulled it from the 5 above it. All right. Anyway, so this is minus 19y. And then, of course, the 4z and the z is canceled out. And this added together is negative 83. So again, now we've gotten rid of z's out of the equations. So now we have to get rid of another variable. I'm going to get rid of y. But to do that, I'm going to have to multiply both of these times something. So I'll multiply this one times negative 2 and this one times 19. That way we will get something that will cancel out for the y's. So let's see, negative 2 times 16x is going to be 32x. I'll put that right here. And then negative 2 times negative 19 is going to be a positive 38y, and that equals, and this is going to be a positive number, 166. So that's basically this multiplied times 2. And then this multiplied times 19, I'm going to put that down here. And 19 times 7 is 133x. And then it's going to be minus 38y, which is what we wanted. And that is going to equal a big number, negative 570. So our 38y's cancel out, which is what we wanted to accomplish here. Now I'm going to have 101x is equal to 404. So our x is equal to 4, because 404 divided by 101, that'll happen 4 times. So that's our x value and our three values that we need to have, our triple ordered set here. Now I need to plug in, oops, this is supposed to be negative. Yikes. There we go. Now I'm just going to take this equation right here, this part on the inside, the 7x minus 2y equals negative 30. I'm going to plug x into that, our x value that we found, the negative 4. So 7 times negative 4 minus 2y equals negative 3. And I'm going to solve for y, and that's going to get me my y value. So 7 times 4, and actually 7 times negative 4, that's going to give us negative 28, minus 2y equals negative 30. add 28 to both sides, we end up with negative 2y equals negative 2. Now, if we divide by negative 2 on both sides, we will end up with 1. So our y value is 1. Now we need to find our z value. So we can pick any one of these upper three equations. I'm just going to pick this one, which is 4x plus 3y plus z equals negative 15. Now I'm just going to plug in my negative 4 for the x and the 1 for the y. So 4 times negative 4. I'm getting those from our values over here. 3 and the 1, that guy right there, plus z equals negative 15. Now this will be easy to solve. Oh no, I'm down to 5% battery. Easy to solve for z. So combining those, I get negative 16 plus 3 plus z equals negative 15. This is why we put lines through z's so they don't look like 2's. Negative 16 plus 3 is negative 13 plus z equals negative 15. Add 13 to both sides. Z is now equal to negative 2. Bingo, bongo, boombo, negative 2. There you go. There's our answer for this group right here. So then moving on to number 19. We have a much simpler one. I can't zoom in anymore. All right. Well, we'll just have to deal with this. So for number 19, we're going to try and get rid of y. So it's simpler because there's only two values. We'll multiply this top one by times 2. And we'll bring the bottom one straight over. 3x squared minus 2y squared equals negative 6. Multiplying this top one times 2, we will get 4x squared plus 2y squared equals 34. Yeah, 34. So now we're just going to add these two guys together. We're going to get 7x squared. This cancels out. And then this is going to be 28. So 7x squared equals 28. Solve for x. X squared equals 4. And then the square root of that is plus or minus 2. So we will try and figure out for x equals 2 first. We're going to look at, I'm just going to use this formula. I'm going to plug in 3, and I'll plug in my 2, positive 2, minus 2y squared equals 6. Now I'll solve for y, and I'm going to get, this is going to be 12 minus 2y squared equals negative 6. Subtract 12 from each side. I'm going to get negative 2y equals negative 18. Then I'm going to divide by negative 2. So y is going to, these are squared, y squared is equal to 9. And that's going to mean my y is equal to plus or minus 3. So basically, I take my 2, which was my x value, and I'm going to get 2 ordered pairs here. I'm going to get 2 plus 3, and I'll get 2 minus 3. And of course, we don't say plus 3, we just say 3. So fix that guy. There we go. Now, if I use negative 2, so x is equal to negative 2. Remember, I had a plus or minus over here, so I need to find some more ordered pairs. So 3 times negative 2 squared minus 2y squared equals negative 6. Just using the same formula. This is going to be 12 minus 2y squared equals negative 6. This is the exact same place we were at over here. They're the same, so I know that I'm going to get y equals plus or minus 3 again. So my next two ordered pairs are going to be -2, comma 3, and -2, comma -3. And there you go, that's number 19. Pretty simple. Okay, moving on to number 20. The area of a garden is 768 square feet, and the length of its diagonal is 40 feet. Find the dimensions of the garden. Well, the area is equal to length times width, and that is, we were given the area, so we can just plug that in. 768 is equal to LW, and we need to figure out what the length and the width are, and we know the Pythagorean theorem is a squared plus b squared equals c squared. So we've got a squared plus b squared equals 40 squared, because we have our c squared is 40. We were given that. So this would be our a, or you could call it the length, and this is our b, which is equal to w. I guess it's better to write it that way. So I'll put in an equal sign here. A is our L, and b is our w. So I'll just change those here. So L squared plus W squared equals 40 squared. So we have these two formulas, and we're going to solve by substitution. These are our two formulas, or our two equations, rather. They came from formulas. And so the first step we're going to do is we'll solve for one of them in this one. So we'll move the L over. So we have 768 divided by L is equal to W. And now we can substitute this into our second equation for W. So we have L squared plus 768 over L, and that squared. And that equals 40 times 40 is 1600. Use the old calculator here. Pretty sure that's true. Yep, 1600. So 42. To show my work here, 1600. All right, L squared plus 768 over L squared is equal to 1600. Now I multiply both sides by L squared. So multiply everything by L squared to get rid of that fraction. So now we'll have L to the 4 plus 768 squared. That gets canceled out. These cancel each other out. But on this side, we still have to have 1600 L squared. So now let's just let x equal L squared. So that means x squared is equal to L to the 4th. So now we can make this look like what we're used to seeing, but x squared plus 768 squared, 1600x. So we reorganize this to be x squared minus 1600 x plus 768 squared equals 0. Now I'm going to need to use the fancy dancy calculator again, figure out what 768 squared is. That's a big number. So we'll get, excuse me, x squared minus 1600x plus 589 824 equals 0. Oh, wow. Looking at a calculator and writing at the same time, not a good idea. This was 589. My penmanship's bad enough. So different writing on the iPad as well. So anyway, we need to find a couple numbers that add together as one thing and multiply together as this other. And you're going to have to trust me on this one. I cheated. I used a website to find this because it's a crazy number, 576. And the other value is 1024. Oh Lord. This is going to be a minus as well. 1024. I sure hope there isn't one on the exam that is like this. This is, I don't know how you'd find that normally. Just trial and error for me. Anyway, x is equal to 576 and x is equal to 1024. Those are our two values. So it doesn't really matter which one we make which, but we can say L is equal to the 1024, W is equal to the, oops, 576. But remember, we let these be equal to something squared. X was equal to L squared, so these are all still squared. So we need to find the square root of both of these. That's why these numbers are still really big in comparison to our hypotenuse, which was 40. So to get these kind of back in line, we need to find the square root of these. So 1024, square root of that is 32. And 576, the square root of that is works out nicely to 24. So those are our values for this guy. Now we'll move on to number 21. And 21 says the area of a rectangular piece of cardboard shown is 774 square inches. The cardboard is used to make an open box by cutting a 4-inch square from each corner and turning up the sides. If the box is to have a volume of 1400 cubic inches, find the dimensions of the cardboard that must be used. Whoa, that is a mouthful. But we do know that length times width is equal to area. It's kind of the same thing that we just said a minute ago. And we are given that area again, which is 774. So we can put that guy right here. And we know volume is length times width times height. And that's equal to 1400. We're given that in the problem. But remember, we're given this corners were cut out. So the length, the original length isn't the same anymore. It's -8. Now remember, it says 4 here, but we have 2 sections that were cut out of the length. So same thing for the width of the box. So we cut out 2 sections, these 2 sections. So our width is -8. And then what we cut out is effectively the height. So we just put 4. And we only have one height, right? And that's going to be equal to the volume of 1400. Now if we divide this by 4, that'll cancel this one out. And yes, this will work out nicely to 350. So we've kind of reduced this volume formula to the quantity L minus 8 and times the quantity W minus 8 equals 350. Now we are going to FOIL this guy. So we have LW minus L8, whoops, 8L minus 8W plus 64 equals 350. Now the reason I did it this way is because I already know what LW equals. It's 774. So I can just drop that 774 directly into this formula instead of doing some other crazy things to get rid of that combination. So we have 774 minus 8L minus 8W equals, and then we'll just take this 64 to the other side and subtract it from 350, and we get 286. Now we're getting close to a formula that we recognize. We have negative 8L minus 8W equals, subtracting the 774, we have negative 488. Getting really close. We have two 8s here. I wonder if 488 divides by 8. So let's divide this by negative 8. Try and get rid of that negative out front over there. That'll give us L by itself. It'll give us W by itself. And then, sure enough, this divides evenly by 61. So now we have a really nicely reduced volume formula. Now, again, we're going to solve this by substitution. So we have L times W equals 774. And let's solve this for L. So we'll just move the W over and divide this by W. Now I can substitute this in for L. So, oops, I forgot to make this a plus. Dividing by a negative, negative 8, that's going to turn it plus. So anyway, we've got 774 divided by W plus W equals 61. Multiply all of this by W, so both sides by W. I'm kind of making a shortcut here, but just trying to show you a representation. That's going to clear this fraction, but it's going to give me W squared equals 61W. Move all this to this side, so we have W squared minus 61W plus 774 equals 0. And then we're going to factor this. Two numbers I think will work are 18 and 43. 18 and 43 does, added together 61, and calculator tells me 774. So we have W minus 18 times the quantity W minus 43, and that, to give me the zeros here, I'm going to have W equals 18 and W equals 43. Now again, this doesn't matter which one we make these, but the length is the bigger one in the drawing up there, so I'll do 43 for L and 18 for W. And that is the answer for number 21. Both of these problems we had to solve by substitution. We couldn't really do it any other way, but that's all there is for this review. Thanks for tuning in for part 2. I hope you guys all have good luck on the test coming up here. And I'll see you on the next one. Please subscribe and hit like, all that kind of stuff. And see you in class. Bye.